Ready to get into some serious Python. Today, we're going to tackle a question that keeps popping up. Is multi-threading enough in Python?
It's a good question, and it's more nuanced than it seems on the surface.
Yeah, we found this really fascinating article by Sachin Sakadeva over on Medium. He calls Python's journey through concurrency, well, kind of bumpy. And he doesn't shy away from the elephant in the room, or I guess the lock in the interpreter.
You mean the GIL? Right?
Yeah, the GIL, the global interpreter lock. It's infamous in the Python world for a reason. But before we get too deep into that, let's rewind a bit.
Yeah, good idea. Back to the basics.
Let's start with threads. Threads came into Python around version 1.5, way back in the late 90s. Using the thread module, which later evolved into threading. The promise was simple, at least on the surface.
Right. Run multiple tasks seemingly in parallel using these lightweight threads, all within a single process.
Exactly. Sharing memory space and appearing to do multiple things at once. Efficient multitasking. At least that was the initial hope.
On paper, it sounded great. A really elegant way to juggle multiple operations without the overhead of separate processes.
But then there's the GIL. Can you explain to our listeners what the GIL is and why it basically throws a wrench into the idea of true parallelism with threads in Python?
Okay, so think of the GIL as this strict bouncer at the door of the Python interpreter. Only one thread gets to execute Python bytecode at a time.
One at a time. So even with all these threads running around.
Exactly. It's like a single-lane bridge. Even if you have a ton of cars, only one can cross at any given moment. All the others have to wait their turn.
I see.
Sachin uses a simple example in his article. He's got two threads running, both trying to do some counting, but because of the GIL, they end up taking turns. No real parallel processing going on there.
So that's the key takeaway, right? Multi-threading in Python, at least when it comes to CPU-bound tasks, doesn't give you true parallel execution like you might find in some other languages.
Right. The GIL limits how much those threads can actually work together on CPU-heavy tasks.
But Sachin does point out that threads have their place. They can be quite effective for IO-bound tasks. So what makes them work better in those scenarios?
Well, IO-bound tasks, they involve a lot of waiting, like waiting for data from a file or a response from a server across the network.
Gotcha. So the thread's just sitting there twiddling its thumbs.
Kind of, yeah.
Yeah.
But here's the thing. When a thread is waiting for something like that, for some IO operation, it actually releases the GIL.
It does.
It does. And this is crucial. This means another thread can jump in and use the CPU while the first one is still waiting.
That's actually quite clever. So while one thread is waiting for the network, another one can be busy processing data.
Precisely. So in those cases, threads can be really good at keeping things moving and making your application more responsive, especially if there's a lot of waiting involved.
Makes sense. So we've got threads. Good for when you're mostly waiting, but not so great when you need pure CPU power. What about when you do need to really crank up the CPU and make use of multiple cores?
Well, that's where multiprocessing comes in.
Okay, yeah. Sachin talks about that. It came along a bit later, around Python 2.6, I think. So how does multiprocessing get around the GIL issue?
Multiprocessing takes a completely different approach. Instead of creating threads within one process, it spins up completely separate processes.
Separate processes, each with its own what?
Each with its own Python interpreter and its own dedicated memory space.
Interesting.
And crucially, each process also gets its own GIL. So they can genuinely run in parallel on different CPU cores. No more single-lane bridge. They can all cross at the same time.
Ah, I see. No more GIL bottleneck because each process has its own private GIL to work with.
Exactly. So with multiprocessing, you get true parallel execution for those CPU-heavy workloads. Sachin includes another code example in his article to illustrate this. It's similar to the threading example, but uses multiprocessing process instead. And those processes, they can truly run that counting function simultaneously. They can each grab a core and crunch those numbers at the same time.
That's pretty powerful. So if you're dealing with tasks that are really computationally intensive, multiprocessing is the way to go.
It's a good option, yes. But as with anything, there are trade-offs.
Like what?
Well, each process needs its own memory space. So your memory usage can go up compared to using threads.
Right, because threads share the same memory space within the process, but processes don't.
Right. And another thing is communication. Exchanging data between those separate processes can be a bit more involved, a bit slower, compared to threads that can directly access shared memory. You might need to use things like pipes or queues to get data from one process to another.
So there's some extra overhead there in terms of communication.
Yeah, It's like having separate houses instead of separate rooms within the same house. You can't just walk over and grab something. You need to send a message or
Yeah,
maybe even use a delivery service.
I get it. So multiprocessing gives you the raw power for CPU-bound tasks, but you might pay a bit more in terms of memory and communication complexity. Now, Sachin then moves on to a different kind of problem. He talks about situations where you have tons and tons of concurrent operations, like handling a massive number of network requests.
Oh, yeah. That's where Asensio enters the picture.
Right. Asensio came along in Python 3.4 and 3.5 around 2014, 2015. It's like a completely different beast altogether.
It is. It's all about asynchronous, event-driven concurrency. And it does all this within a single thread.
Wait, single thread, how does that even work with so many things happening?
Well, instead of relying on the operating system to manage multiple threads or processes, Asensio uses a single-threaded event loop.
An event loop, huh?
Yeah, it's like this central coordinator. You define these special functions called coroutines using the async and await keywords.
Coroutines, right.
And these coroutines, they can pause their execution while waiting for something like an I/O operation.
Okay, so they're not blocking everything else while they wait.
Exactly, that's the key. While one coroutine is paused, waiting for the network or something, the event loop can switch to another coroutine that's ready to run.
So you can have all these tasks, these coroutines, seemingly happening at the same time, all within one thread.
You got it. It's kind of like cooperative multitasking. Everybody takes turns, but they do so efficiently without blocking each other.
I'm starting to see why Sachin says Asensio is a game changer for network-heavy applications.
Right. It can handle huge numbers of concurrent connections without the overhead of managing lots of threads or processes.
And Sachin gives a nice little code example. The fetch data function shows how you can use await asensio.sleep to simulate an I/O operation without blocking the whole program.
Yeah, that's a really neat way to illustrate how Asensio works. It just pauses that one task and lets others continue running within that single thread.
So what are the main advantages of Asensio then?
Well, as we said, it's very efficient, especially for high concurrency I/O. You can handle tons of tasks without using up a ton of resources.
Right.
And because you have more control over when tasks switch, you can often avoid those nasty race conditions and shared state bugs that can happen with threads.
Those can be a real headache to debug.
They can. And Asensio also provides some really elegant ways to compose complex sequences of asynchronous operations.
So sounds like it's pretty awesome. But are there any downsides?
There are some things to be aware of. One thing is that Asensio really shines when you're using libraries that are designed to be non-blocking.
Non-blocking, what does that mean?
It means that they don't just stop everything and wait when they're doing something like reading a file or waiting for a network response.
I see. They need to be built to work nicely with that event loop.
Exactly. So if you're using older libraries that do blocking I/O, you can't just slap an await in front of them and expect Asensio to magically make it work.
Got it. You need to choose libraries that play well with Asensio.
Right. And another thing to keep in mind is that Asensio itself doesn't inherently utilize multiple CPU cores.
Even though it can handle so many tasks, it's still running within a single process and a single thread.
Yes. And while you can combine Asensio with threads or processes, it can add complexity.
So not as straightforward as just using threads or multiprocessing on their own.
Right. But even with those considerations, Asensio is incredibly powerful for those network-heavy applications. It's really changed the game for a lot of web services and APIs.
Yeah, Sachin mentions that it's heavily used in frameworks like AOTTP and HTTPX, which are really popular for building modern web applications.
It's become essential for high-performance web development.
Okay, cool. So now we've covered threads and the GIL, multiprocessing, and the async world of Asensio. Sachin also talks about the concurrent.futures module and its thread pool executor and process pool executor. Where do those fit in?
They're kind of like a nice middle ground. They provide a higher level, more convenient way to work with both threads and processes. They were introduced in Python 3.2, if I remember correctly.
And they offer a simpler way to manage the whole process, right?
They do. You don't have to worry as much about the low-level details of creating and managing those threads or processes manually. The executor does a lot of that heavy lifting for you.
So you just tell it what you want to do, and it takes care of running it using threads or processes as needed?
Pretty much, yeah. Sachin has an example using Thread Pool Executor that demonstrates how you can submit tasks, like calculating the square of a number, and it handles running those tasks using a pool of threads. Very straightforward.
I see. It seems like a more manageable way to get the benefits of threads or processes without getting bogged down in the nitty-gritty.
Exactly. Executors simplify things a lot. They're a really good option if you need threads or processes, but want cleaner, more readable code.
So let's bring it all back to Sachin's central question.
Yeah.
Is multi-threading enough? Based on everything we've discussed, what's your take?
Hmm. It's a bit tricky to give a simple yes or no answer. I think, as Sachin concludes, it depends.
Depends on what.
It depends on the type of tasks you're dealing with. For pure CPU-bound tasks, multi-threading in Python with that GIL bottleneck probably won't give you the true parallel performance you might be looking for.
Right, but it can still be helpful for simpler IO-bound tasks where you're spending more time waiting than processing.
Absolutely. And don't forget, Python gives you this whole toolbox of concurrency options. It's not a one-size-fits-all situation. You have choices.
And Sachin lays out those choices really well in his table. He recommends Asyncio, plain threading, and thread pool executor for IO-bound tasks. And for CPU-bound tasks, he points to multiprocessing and process pool executor.
What about those situations that are kind of a mix of both, or just more complex in general?
Well, for those more intricate cases, his advice is to carefully combine these tools.
To mix and match.
Yeah, it really emphasizes the need to understand the nature of the task you're trying to accomplish. There's no magic bullet. It's about choosing the right tool for the job.
And it seems like this is still an evolving area in the Python world. Sachin even teases potential changes coming in future versions, specifically mentioning OPython 3.13 plus Adaman, hinting at possible GIL-related developments. Yes, it's definitely something to keep an eye on. The core Python developers are constantly looking for ways to improve performance and address the challenges of the GIL. Any significant changes there could have a big impact on how we approach concurrency in Python.
So for our listeners who might be new to all this, let's do a quick recap. Python threads are pretty easy to start with, but that GIL can limit their effectiveness for CPU-intensive work.
Right. And then you've got multiprocessing, which gives you true parallelism, but might come with some extra overhead in terms of memory and communication.
And then there's Asyncio, which is super powerful for handling lots of concurrent I/O operations, but works best with libraries designed for that asynchronous world.
And don't forget about those handy executors, which provide a cleaner, more managed way to use both threads and processes.
Lots of options. But as we've been saying, the key takeaway is to understand what kind of tasks you're dealing with and choose the right tool accordingly.
Couldn't have said it better myself. Think about whether your application spends most of its time crunching numbers and pushing the CPU or waiting for data from files or the network. That should really guide your choice of concurrency approach in Python.
So as a final thought for our listeners, maybe go back and look at the types of applications you're building or the code you're writing. Think about where those bottlenecks might be. Is it CPU or I/O? And then consider how these different concurrency tools might help you improve performance or make your code more efficient.
And for those who want to dive even deeper, Sachin's article has some great links. I especially recommend checking out the one about the Python event loop. It's a great way to get a better understanding of how Asyncio works under the hood.
Awesome. Thanks for breaking all this down for us. It's definitely a lot to think about, but hopefully this gives our listeners a good starting point for navigating the world of concurrency in Python.
Absolutely. It's all about understanding your needs and using the right tool from Python's ever-expanding toolkit.
Until next time, happy coding.
Happy coding.